All right, we're going to do the last 5 questions in number 7. This is not a mistake, the blank one. You can think of it like a bingo space. It's like a free space. I just thought you only needed to practice 5. So the first triangle, we could recognize it as a 30, 60, 90, or we can use trig. Do whichever you want for this one. I noticed that it's a 30, 60, 90. So I know that if my hypotenuse is 16, that my shortest leg would have to be half of that. So I know that y equals 8. And then I know that if my short leg is 8, that my long leg would be 8 times the square root of 3. So we could write that for 8 times the square root of 3. Now if you'd rather use trigonometry, I might say cover the y, since let's say that we're looking for x. We could cover the y. And now this looks just like a mile marker question. And I could say that the cosine, because I want to use adjacent and hypotenuse, the cosine of 30 degrees equals x over 16. So 16 times the cosine of 30 equals x. And if you type that into your calculator, 16 cosine 30, you get 13.856 if you round. And if you type in 8 times the square root of 3, you get the same exact number. So we're going to round this to 13.856. Okay. You could also use the sine function to find y. So you could say the sine of 30 is y over 16. 16 sine 30, plug that in your calculator, you will still get 8. So these are our final answers, whether you use trig or you used special right triangles. Next question, a square separated by a diagonal. So we know we've got a 45, 45, 90. I think this is an easy one to use our special right triangle knowledge. The legs have to be the same since it's isosceles. So x equals 8. And then the hypotenuse is going to be that leg times the square root of 2. So y is equal to 8 root 2. Let's pretend that you didn't want to do it that way. If you wanted to use the sine function or cosine function, we could cover the x. Let's pretend we don't know that, but we know this is 45 degrees. So I could say the cosine of 45 degrees is adjacent, 8 over hypotenuse, y. So this becomes y equals 8 divided by the cosine of 45. And then in your calculator, 8 divided by the cosine of 45 is 11.314 approximately, and 8 times the square root of 2 is the same exact number. So you can see that you'll get the same if you use trig or special right triangles. I would take either the radical or the decimal. Just make sure you round it to 3 decimal places. All right, moving on. These problems, the last 3 on the page, these are not any more difficult than the mile marker questions if you just do them one variable at a time. So when I'm solving for x, I'm just going to completely cover y. So if I look at this, I now have a tangent problem. So I could say the tangent of 48 degrees is opposite x over adjacent 11. This becomes 11 times the tangent of 48. To give me x. So 11 tan 48, I get 12.217 approximately. So x is approximately 12.217. You can, if you use the equal sign instead of the approximate symbol, I'm not going to count off for that, but I just want to be clear that this is an approximation, whereas this is an exact number. So there is sort of a difference here between using this exact value and this approximation. Okay, now if we want to find y, I would not recommend using x to find y. I would cover x and solve the problem like x were not there. So this becomes a cosine problem. I could say the cosine of 48 degrees is my adjacent side over my hypotenuse. So that's 11 over y. And then that becomes y equals 11 divided by the cosine of 48 degrees. So again, in your calculator, 11 divided by the cosine of 48. we get 16.439. So y is approximately 16.439. Now, you could have also used the Pythagorean theorem once you found x to find y. You know, just if you do that, you're doing it with a rounded number, so you might get a decimal that's a little different than mine. Okay, last two problems. You've got three things to find on this triangle, a side and two angles. And I would find x first, and I would use the Pythagorean theorem. So if a squared plus b squared equals c squared, this is an example of when I would do c squared minus a squared to get b squared. So I'm going to end up doing 18 squared minus 5 squared. That will equal x squared. So 18 squared is 324. 5 squared is 25. So I get 299 equals x squared. I'm going to take the square root of 299. X is approximately 17.292 because we took the square root of both sides. All right, so we found x. So now when I go to find y, I'm going to try not to use x, because what if you made a mistake finding x? If you find y and you only use 5 and 18, you wouldn't possibly use this mistake when you're finding y, if that makes sense. You might still do it and get the right answer though. So if I go to find y, I'm going to try to use just these two sides. So that means I'm going to use sine. So I would say the sine of y is equal to the opposite, 5, over the hypotenuse, 18. I take the inverse of both sides, and I get the inverse sine of 5 over 18 equals y. In your calculator, you can go to second sine, inverse sine, 5 divided by 18, and we get 16.128. So y is approximately 16.128 degrees. All right, last but not least, if we want to find z, we're going to find z. We could add, we could subtract y from 90 degrees to get z, because all three of these have to add up to 180, and we already know this angle is 90. I'm probably going to use trig again, because what if I made a mistake finding y? And then if I use y to find z, I'm using that mistake again, so I'll get the wrong answer for z. So I'm going to use trig. I'm going to use this little blank space over here. And we could say that if I'm looking at angle z, I've got an adjacent and a hypotenuse I know. So I could say the cosine of z equals my adjacent over my hypotenuse. So I'm going to do the inverse of both sides, and I end up with the inverse cosine of 5 over 18 equals z. So second cosine, 5 divided by 18, I get 73.872. So z is approximately 73.872 degrees. Now we can check these two answers together at least by making sure they do add up to 90, because for all three of those to add up to 180, these two must have a sum of 90. So if I add that plus 16.1276, I guess I should have said 128, I get 89.999, and that's just because I rounded. Had we added these together, we would have gotten 90 exactly had I not rounded those. So that's looking pretty good. Very last problem. Really not any more difficult than that one, maybe less difficult. We just have a decimal in here. So if I want to find x, if I cover y, it's now just like a mile marker question. I'm going to use tangent. The tangent of 28 degrees equals x. Wait, nope, sorry. Tangent is opposite over adjacent. So 4.1 over x. Opposite over adjacent. So now I would rewrite this as x equals the 4.1 divided by the tangent of 28. And when we do that, 4.1 divided by the tangent of 28, I get about 7.711. So x is approximately 7.711. Okay? Last but not least, we can find y. Now, I could use the Pythagorean theorem to find y, but again, if I made a mistake finding x, I'm just going to make that mistake again if I use x to find y. So instead, I would use trig. You could use whichever one, though. But so if I look at this, I'm going to have sine, because I've got my opposite and my hypotenuse. So the sine of 28 degrees is equal to the opposite, 4.1, over the hypotenuse y. So I can now rewrite that as y equals 4.1 over the sine of 28. So 4.1 divided by the sine of 28, I get 8.733. You could check these with the Pythagorean theorem if you wanted to. 4.1 squared plus 7.711 squared should equal 8.733 squared. All right, that's it.